software-defined networking on top of our physical layer, right? So this is basically the overlay that we build, and this overlay started to be and it was created for many years already. And as you guys know, Azure grew rapidly, and we actually develop all the other features based on our needs and based on also customer needs. We did lots of optimization there, and right now part of the work that we are doing with the Azure ecosystem is try to standardize it in order to reach for us kind of like a next level, because the stuff that we were able to do in the software, it scales to the point, right? And this is where we need rest of the community to help with basically creating much more performance for basically customers, right? This is where the Dash community comes in with potential standardization of how the APIs will look like and this kind of stuff, right? And as we were building our ecosystem, right, we of course develop our stuff from the Microsoft perspective, and also something similar AWS has, Google has, and other companies, right? So right now we released the first version of the standardization, kind of like open for comments, open for additions, and the work that Gohan did and the team to release the SAI, which was the software facing interface. So this is the interface that is basically facing the actual hardware, right? And I would like to talk slightly about the next part of this high-level architecture that Christina mentioned there. So basically how we will be controlling this, right? So SAI is something that will run is basically implemented by hardware, and Sonic system will basically be calling SAI, right? However, from the point of view of the control plane, so from the point of view of our SDN control plane, so whenever customer clicks something on the UI and they request, for example, VNet creation, and they request, for example, those IP allocation to be there, they request services like private link, service tunnel, they set up peering and we basically, this call later calls to us. We, on the control plane, allocate all the required resources, decide where, based on the capacity the VM should be put in, do we have sufficient networking capacity, and prepare all this configuration, right? And later, it's end up in a way that our control plane needs to actually call the actual hardware in this case, right? And currently we have a software which is the VFP, right, to kind of configure it, right? So the calls that we'll be calling, it is basically the Northbound facing interface. This kind of API based, how the customers will be able to control in the same way as in a Sonic switch. There is an API interface which is GNMI that is being used to control the switch behavior. In the same way, we want to standardize on this. So the GNMI is the open format that we are basically extending right now. Apart from the normal functionality that right now it offers, we will be offering an additional set of APIs that will be designed on top of the GNMI that will do things related to SDN, right? So right now we are working on this, the ETA for the potential first version of the creation for this API, and to publish this is most likely around end of January, maybe slightly into the February. We'll see what it do. So in general, we'll have the API for working with the abstraction layer for the SDN, right? So all the abstraction layer which were already described in the document that is on GitHub, right? Which means that we will have a front northbound facing API for creating and deleting the ENI. So this elastic network interface. So we'll be having the specification how to create this ENI, how to remove this ENI. We'll have the specification how to create the ACL group, right? And how to specify the rules, right? And then the interface is to create the routing. All the routing is, of course, like LPM based, the same as described in the documentation. Ability, once the routing gets established for functionality, which is, for example, customer will plan, let's say 10/8 is my VNet address space, right? Of course, different instances of the VMs are lying in different physical locations in the data center. So this is where the mappings comes in a place, because customer usually calls, I want to connect, for example, from the VM which is 10.0.0.5. They want to connect with the VM 10.0.0.6, right? And the customer just thinks from the point of view of this like kind of overlays IPs, right? However, In order for us to transfer the traffic, we of course need to encap this using either NVGRE or Vxlan type of encap, right? And we need to, in outer header, this is how the SDN works, right? In outer header, we need to basically provide specific correct IPs of both the source node when the VM is and the destination node. In this case, the destination node, if this is Sonic, sorry, not Sonic. If this is Dash, will be basically the BGP VIP of the car that is doing this, right? So all those APIs will allow us from the Northbound part to basically control this behavior. And then there will be an agent that will develop and publish this as an open source community. And we're hoping the community will also help develop this agent, which will basically provide a translation, right? So the Northbound-based APIs is basically something will be exposed over gRPC and it will be callable from the control plane. So that's the high level stuff. I'm not quite sure how much would you like you guys for me to go lower level. I noticed there are some hands raised up, so
right. So
maybe we can grab these questions right now. Yeah,
sure. So Silvano is from Pensando, and then we have Chris from Keysight. And so Silvano, why don't you go ahead?
Yeah, very simple question. I assume that in this drawing, each DPU will be from a management perspective and from the GNMI perspective will be an IP addressable unit. And so each DPU will expose his own GNMI that will be completely unrelated to the GNMI of other DPU.
That's correct.
Thank you.
That's correct.
Thanks, Michael.
So even if those the DPUs will be, for example, later built maybe in one chassis or this kind of stuff, right? We want to be able, from the control plane perspective, to address separately each of them. So each of them will expose the management IP, and this is how we will be able to control them. This is how we will be able to, for example, pair one card with the other card from the point of view of availability. So yes, that's correct, Silvano.
This will be also true in the smart switch or not?
Yes, in the smart switch, so there is two things to this, right? Preferably yes. At the same point, we know that there is a problem with we don't want to also waste lots of IPs, right? So that's also open question. If this is IPv6, most likely will basically be if the management IP is IPv6, will be per DPU, right? If this is IPv4, it's possible that we may need to optimize this and basically create some mini agent, for example, inside the smart switch, they'll be forwarding those requests just because of the IP addressing and potentially some optimization there.
Yeah, but you can do it by port or something like that.
That's correct.
Okay, so it looks like Chris is next. Chris, I'm just moving through the questions, trying to make the most of Michael's time. Go ahead, Chris.
Hi, Michael. Thanks for the presentation. When you come out with the standards, are they going to be based on, for example, open config and or possibly non-open config type models? Can you give us kind of an overview of the GNMI schema without diving into the file necessarily?
Yeah, so not exactly they will be based on the open config. So I look at the open config, right? There are some things that open config is doing, right? But at the same point, we are actually not using open config type of schema in our SD data center, right? I think AP config, like open config, is like a more generic, right? Here we want to use kind of like a incremental approach in a way. First, deliver what is actually minimal stuff required. So don't create like a big feature set as the first stuff. And if for example we will not be using most of those feature sets, right? So we want to basically, this is all about performance, I would say. So there is also no point to have asking, for example, the vendors to implement all the complex feature set. I would say like polluting the device to be very generic, right? If at the end the specific clouds, which is for example Azure and later for example AWS or Google or different open community, will be mostly using the subset of this, right? Because we are losing performance on the P4 pipeline potentially and this kind of stuff, right? So I would say it will be subset of the functionality.
Okay,
at the beginning to start with. Yeah.
So okay, just one question, Chris. We can move on to Jai.
Yeah.
Okay, great. Jai, go ahead.
Hi, Michael. This is Jay. I'm from Broadcom.
Awesome.
So A couple of questions. So I think I'm going to do a follow-up on previously asked question. So in a smart switch, you said that if it's IPv4, we may want to optimize the IP address and present the whole thing as a single instance, meaning there is a DPU cluster. So in that case, today SDN controller does all the workload placement, HA management, and everything. So
That's correct.
so you expect that agent to run on a switch CPU?
No. I don't expect this agent to run on a switch CPU. So the actual stuff with regards to management of the capacity, right? We have this in our own SDN controller, which is separate service, right? It doesn't have to be high performance. This kind of stuff has more memory and has entire inventory and this kind of stuff, right? So this service, this SDN controller management service, will be mostly the service which will be deciding that this specific let's say card needs to be programmed, right? And it will be calling this card, but most likely it will be calling this either through maybe the port-based approach that Silvano mentioned, that this will be the same address, just we basically exposing this interface in 3 different ports or something like this, right? So I don't expect any complex logic to run on the switches actually, because there's a lot of complexity with regards to correctly managing the basically allocation of devices, also ability to, for example, if one device dies, like one card dies, and this card, because of the high availability, was paired with the other like a second card, right? Then we need to, for example, RMA this card, but the rest of the switch is still working, right? So if this card was paired with some other card, the other card that is still working, it cannot be left in this state that there is only one single card working, right? So we'll find a different pair, so different paired card that we most likely on different switch, and we need to pair it, right? And from the just switch perspective, the switch doesn't have the top level view of what are other switches are there, how they are positioned, the data center from the proximity, this kind of stuff. So there'll be no complex logic there inside the switches.
Got it. So basically you're saying that in this case, let's say the switch has, n DPUs, and the ports on the DPUs, they will be presented as logical contiguous port. And any kind of management further is done within the switch itself, right?
That's correct. That's correct. One open, I want to add additional stuff with regards to this management, right? There needs to be a way to upgrade firmware, for example, for the specific cards, and not as for example, not the entire switch together, right? Because we would like to be able to, for example, shut down one card to upgrade firmware on this card, and then, for example, shut down another card to upgrade the firmware of this card, because the updating entire, for example, switch will shut down all the cards together, so potentially more traffic will be impacted. So we should also keep this in mind, that we want to have granular control over those cards.
Got it. I think that's probably HA related, so we will have more questions. So I'll leave that. I have just one more question before I give other people a chance. So how about so anytime you provision a ENI over a VXLAN tunnel going to VM, what happens to the underlay? So underlay management is also with the SDN controller, or they're decoupled completely?
By underlay management, you are talking about for example, the physical network, but you are talking about the IPs that we'll be using for encapping?
I mean, the state of the port. VXLAN is going over the physical interface. Physical interface is down. You will see the VXLAN is down, right?
That's correct. So each card will have so basically each card will be sending their own traffic. So each card is connected directly to the Tor, right? So what we are doing and prototyping on our side right now is that this kind of like physical interface, right? So this physical interface is set up at the beginning once, for example, and the card gets assigned for the card. Hey, this is, for example, the BGP IP for the card on which the card will receive the traffic, right? In case of HA case, we actually want the card to potentially be in long-term like active mode, right? So potentially either there'll be one BGP address or 2 BGP addresses that will be used, right? But then the ENI are kind of on top of it, which means that if we assign 5 ENIs, 3 ENIs, this kind of stuff, right? Then there will be still the same BGP address, right? And now you are talking about the VXLAN with regards to potential. Each VLAN has a different VXLAN ID, right? So VXLAN key. And one thing that I want to add here, right, from this point of view of the ENI perspective, that at least on our side, the the VLAN is or Vxlan is not really a property of the card, so it's not shared by the card. It's more the property of the ENI. So in this case, for example, you can have multiple ENIs that are assigned to the same card, right? And each of those ENIs can be either in the same Vxlan or can be, most likely they will be in, for example, different Vxlan, right? And so the Vxlan is not like top level object, more like Vxlan is kind of something that only ENI reference, right? However, from the point of view of the memory consumption, right, it is okay to have a VNI as a top level object from the point of view of the mappings, right? So the mappings would be controlled per VNI. VNI can be top level, but at the same point, the VNI doesn't exist by itself. It's more like the ENI exists, and ENI may refer multiple VNIs, right? So the concept of adding ENI or removing ENI is basically I'm adding ENI with all the configuration that, hey, this is your primary VXLAN for the routing for this other space or this other space. Use, for example, the other GRE keys to kind of communicate, right? So it's not like top level object that is set up for the underlay. The only thing that underlay knows from the card perspective, like a top level perspective, this is the VIP that the traffic arrives on.
Yeah, okay. And one last question. Sorry, since I have the opportunity. So how about the bandwidth allocation, etc.? How do you know that given VNI or ENI or a workload placement need to happen on this VM? How do you do the available bandwidth? Is it Everflow which you use or some other mechanics?
Yeah, so for available bandwidth from the allocation perspective, right, we are actually assuming that the card bandwidth will be utilized close to 100% from the point of view, because those will be the workloads which actually are not targeting every single VM in the cloud. They will be mostly targeting bigger customers, and bigger customers basically using more bandwidth, right? So based on this, we will know how to spread the ENI. Also long term, we don't want, for example, one ENI to be only on one card. For example, in the paired card, we were also thinking on our side to provide something similar mode like Icmp based traffic redirection, but it will be not like equal cost path that goes to the same VIP. But on our side, when we will be basically splitting the traffic that goes from the actual VM and from the node, right? There will be consistent hashing algorithm that will split the traffic across, for example, 3 different VIPs, right? So each card which will advertise different VIP for the physical network, the underlay will receive, let's say, 1/3 of the traffic, right? And this is how we can allocate this, right? So from the allocation perspective, we are assuming that we need to have capacity on the T1s or T0s actually to handle all the full bandwidth of all the cards. So if the card is, for example, 200 gigs, we need to have sufficient capacity to handle 200 gigs on the T0.
Got it. All right. Thanks, Michael.
Lisa.
And we definitely will be doing over provisioning at some point, right? Yeah.
Go ahead, Gerald.
Gerald, yeah.
But I also think that at least in our network, you can meter the traffic as it comes in, something. But we do rely in our network on the fact that the VM sits on a server somewhere. It's already metered. It's metered before it exits. So it's not like they can just grab any amount of bandwidth. They're limited to what they can put in the network, whether they're talking to another VM or whether they're talking through this appliance device.
Do you dynamically move ENI to a different VXLAN based on the bandwidth changes, consumptions dynamically? Is that a...
No, we will not dynamically based on the bandwidth changes redirect traffic to a different VXLAN. Okay. So the VXLAN is more the isolation AT&T. So it's kind of one-to-one mapping with the VNet. So it's so basically 2 VNets. So let's say one VNet belongs to Pepsi, the other for the Coke. They have completely different VXLAN ID. So even if for some reason the mapping anywhere is outdated or this kind of stuff, and traffic gets redirected to, for example, different card or this kind of stuff, right? The card will have only the ENI configuration to dig up this specific set of VNIs that is actually supposed to talk to, right? So the VNI is mostly not for the load balancing, it's mostly for the isolation perspective.
Isolation is good. Just for the bandwidth handling purposes, it is possible to instantiate another VXLAN to traverse a different path just to handle the dynamic changes in the bandwidth per customer, just some in those lines. Yeah.
So can you tell me more about the scenario of instituting another Vxlan, because Vxlan is because based on my what basically how we are using Vxlan, right, is Vxlan is really a tunnel ID, right, but it's used for the outer end cap, right, so it's more like a key of the communication, right, but how do you set it up between which source and which destination, right? We are like how we are using this in SDN and how we want the device to actually use it, right? Is I know that, for example, from the point of view, like I'm familiar also with Linux, FreeBSD, those kind of stuff, right? I used to spend lots of time there, and I know that, for example, like you can do like ipconfig and set up like give0 interface or this kind of stuff when you are setting up GRE tunnel between this source and destination, and the tunnel is kind of static from this point of view, right?
Yes.
And if you want more, you are setting it up more, right? But this is not how we are using SDN, right? So because the SDN is more like if you have, for example, 1 million VMs in your big VNet, right? Which, for example, belongs to one of the big customers, right? Those VMs can be all over the data center, right? From our point of view, we are actually on our side, we are not plumbing or we are not pre-creating the 1 million tunnels, because by itself, like one specific VM usually doesn't communicate with all the other instances unless it's doing something like a ping mesh, right? But normally the communication, even though from the isolation perspective, from the configuration perspective, the VM belongs to the VNet that has 1 million devices. Usually one VM doesn't communicate with all the other million devices. So we don't pre-create those tunnels. The only thing that we have is, which in our spec, which is called the mapping. And it's more like dynamic from the point of view that only when we see the traffic going to some specific customer address, which is called CA, which is the VM internal VM IP, right? Only then we do the lookup against the, okay, we want to go to this CA, okay, this is the physical address which you call PA, which should be put in outer NCAP, right? And this is the GR key that you should use, or Vxlan ID. And this basically is dynamically put in the NCAP, right? So we don't pre-create those tunnels as kind of like lots of interfaces in Linux, right? We just have one single interface. Is like, hey, this is the interface for the outbound, let's say, right? And as the packet arrives, as the packet is being processed, we dynamically stamp the output destination IP, and this is the GRE key, right? So this is how we are doing this, right?
I see. Yeah, I was
Hey,
thinking I can discuss with you offline. It's about using Vxlan Multicast, where some of the, nodes can join a particular group, and then we distribute traffic, and we can have a full mesh there as many nodes want to join, and then we can create a completely different set of nodes, another mesh, and spawn different fabrics based on that.
Yeah, so let me address the multicast part, right? So one of the reasons why you guys will notice that none of the big clouds have support for the multicast for this kind of stuff, right, is just that our network is too big. And if all the physical devices will start advertising their own information that, hey, I'm joining this group or I'm leaving this group, this kind of stuff, there'll be too big chatter on the network. And this is also one of the reasons why implementing multicast in cloud is just very, very costly from the traffic perspective, right? So there is no multicast in the cloud, right? So it's only driven based on the mappings between, okay, this is the source, this is the destination, right? And this allows to save the bandwidth on the physical network, right? And also allows to optimize the traffic, right? The multicast will just not scale from the amount of traffic that we are handling, right? It just needs to be direct traffic between two VMs. We cannot afford for big chatter that is happening on the wire. So unfortunately, we cannot use multicast on the physical network.
Thanks, Michael. Yeah, Lisa, go ahead.
Yeah. Thanks, Christina. Yeah, hi, Michael. I have two questions. From the HA's point of view of what you described so far, is it correct to understand that SDN controller is the only one that having knowledge of HA? There's no specific requirements such as syncing across, whether it's SDN appliance or the smart switch?
So the requirement with regards to HA is that the SDN controller is the one that selects what are the pair of the, for example, cards, which will have the same kind of, which will have the same gold state and will basically handle the same flow in kind of like long term in this kind of like active state, right? However, from the requirements perspective, is like SDN controller is the one that will be selecting those cards, yes. SDN controller is the one that will be always scoping the control plane state, which means that, for example, if card A and card B, which is somewhere else, needs to support some strategic GNI. The SDN controller will be the one who will be calling GNMI on card A and calling GNMI on the card B to say, hey, configure this ENI, and it's the configuration of the ENI, and then, for example, update mappings for the communication. And it will be doing this for both cards, right? With this, you guys need to be aware that there is in the cloud, in the distributed system, there's this eventual consistency, right? So there is no guarantees that will card B within, let's say, milliseconds or this kind of stuff, right? That the state may just arrive later, right? The only requirement that we have on the card from the HA perspective is to ensure the when they, for example, we plumb the ghost state to the card saying, hey, you are the card A and you will pair with card B, and this is your guys' respective IPs, right? Then those cards set up the channel between themselves for the purpose of basically flow synchronization, right? And be able to basically replicate the flows, because flows, if in the high CPS system, right, we actually from the control plane will not be replicating flows, right? This needs to be part of the HA design. That, for example, either the traffic arrives to, for example, one card, and this cards after processing send the traffic out plus send additional packets to the backup device, so that is also the flow, right? Or the solution that, for example, the traffic arrives on the card A, and the card A actually doesn't send it back, but doesn't send it out, but basically send the card B. And after card B and card A establishes the flow, then basically it goes back to card A and it sends out, right? There needs to be some synchronization, and this we kind of leave it open for the vendor to kind of provide the most efficient way to synchronize it, right? And the most important part with regards to HA, we'll have separate document on this. This kind of more advanced stuff is more about that two cards may be in different state at this part, right? So as part of the flow replication, we cannot do this in a way that we reevaluate rules on one device and send the original packet just without any metadata to the second device, because second device may be slightly behind the goal state on forward the goal state. So there needs to be some additional metadata sent as per the flow replication to make sure the entire flow is established in the same way in case of the failover, right? Because the thing that from the customer perspective, right, if customer has lots of connections, right, if there is some problem with device and device dies, customer is kind of okay seeing, I mean, not fully okay, but if he sees some retransmissions of the SYN, right, sure, sometimes happens during failover, maybe for SYN retransmissions, right? But if he has already established connection and this connection breaks, this is completely no-go for the customer from the HA perspective, right?
Got it. Yeah.
But this will be more discussion about the HA later, and we will also
sure.
this more.
Sure, we're looking forward to the document.
Do you have a second question,
no, you
Lisa?
have a document. But they have a document, so they should read that before we go on those discussions. So don't wait for the document. The document is published.
We had provided via the Teams channel, Lisa, to your company the documentation around HA. So if you don't have it, reach out to me and I'll get it to you.
Okay, great. Thanks a lot.
Oh, Christina. I didn't know that you didn't put. Why is it not put in the public domain, Christina? There's nothing.
We decided on the documents that are published publicly are the ones we decided on when we initially uploaded, and that's what we were going to share at that point. So,
Michael, I don't see any reason why we wouldn't make that one public, because people can contribute to that document.
Yeah, let's revisit this. Yeah, I also
we did
think
load balancer. Yeah, we did the load balancer, the testing, and then the packet transforms, and that's what we agreed on in the beginning. So if Michael wants me to convert it and upload it, we can do that.
Yeah, I think HA we can convert it and do this. The HA is more like high level stuff.
Okay, great. Yeah. Suresh,
the reason I wanted the reason I wanted updated, Christine, is because I know that some of the suppliers here already do some HA, and so they have ideas, and those ideas can be used. We're not exclusive to ideas, so I would like them to look at the document and debate.
Sure.
You know, if there's better ways or if there's different ways, then we can discuss that.
Yeah, absolutely. Michael and I will work on that. Lisa, are we finished with yours? Do we move to
Suresh? One quick question regarding the extension for the operational API. Michael, if you can elaborate more on that a little bit more, maybe at a high level, and talk about what are the area where the attention is. Is that mainly for the flow? the hardware learning flow and statistic, or yeah.
So you are talking about the Northbound API that I just discussed at the beginning?
Yes.
So the Northbound API is just the way that we can basically control it through the control plane, right? Because the SI API is something that you guys implement, but is not exposed as the gRPC or anything like this, right?
Yes.
And it's not in this GNMI format, right? So we need to have a way to call the card remotely, right? And this is basically gRPC, which is the entire community was standardized on gRPC and GNMI, right? So it's more about creating abstractions layer on top of the SI interface that you guys already have. SI interface that you guys already have. That will be just, okay, this will be API that will be calling, and there will be some agent that will be translating this and driving the goal state and calling the SI API to, for example, configure it.
Okay. Will you be able to share some document in terms of this extension that you're going to introduce?
So that's my point. We are currently working on this, right? So tentatively we'll share the first version of this kind of new GNMI interface, most likely around end of January, beginning of February. Yeah.
Got it. Thank you. Thank you.
Thanks,
Thanks, Christina.
Yeah, Suresh, go ahead.
Thank you, Christina. Hey, Michael, this is Suresh from Fungible. Thanks for the clarity on the SDN controller inserting flow rules into the card. So my question is, in this path, where do you see Sonic as a nose fitting in? Do you expect Sonic to be running on the DPUs?
Yes.
There is always
And I'll tell you, and I will finish, and then I can add some more stuff about the Sonic.
Yeah, please go ahead. I think you're answering my question already.
So the answer is yes, and the main reason is that Sonic provides also more. Like, for example, we will not be specifying information about the telemetry. Sonic has already information about basically how to push the telemetry and those kind of stuff, right? So they have lots of agents that are actually providing this kind of basic configuration. So Sonic is more like open source ecosystem, right? Where as part of the Sonic OS, Gohan will prepare, hey, this is the minimal set. That, for example, we need this, but we don't need this, right? That will be running this, right? And on top of it, basically, we add additional container that is responsible for the SDN, right? But at the same point, we will not reinvent the stuff that is already in the Sonic that we also need, right? So, for example, we need telemetry, right? Some packet capture, diagnostics, or this kind of stuff, right? Sonic already has it, right? So there is no point for us to reinvent it from scratch. Right? That's why we kind of expanding the Sonic ecosystem by Sonic was controlling like physical network, and we are adding SDN capability, right? You don't need to compile it in if you don't want to have SDN capability, but if you want SDN capability and don't need, for example, some switch related stuff, you can basically remove some parts, some container, add a different container.
Okay, understood. And just a follow-up question to that, assuming the scenarios where a physical server may be having multiple smart NIC cards in it, do you see each of them as different endpoints that, or, are there cases where, you probably want to have the traffic coming from the VMs to be load balanced across both the NICs instead of having them independently managed?
So let me answer the question about the load balancing, this kind of stuff, right? So one thing that we really care about in the cloud, right, is availability and not having something which is called spoof, which is single point of failure, right? So in this case, for example, even right now when we are load balancing, we usually, for example, have a server that's connected, let's say, to two TORs to basically have a traffic through one TOR and the second TOR in case one TOR dies, right? And the same here, if, for example, there is a switch that has multiple cards, right? The load balancing, if we will provide load balancing, it will most likely not be between multiple cards on the same switch, because this doesn't provide any availability for the customer, because if the switch dies because it's connected to one power outlet, right? If there is no power on this power outlet, right, customer has no connectivity, right? That's why the same as, for example, traffic is balanced across multiple TORs. In the same way, it will balance across multiple cards. Yes, but it will be mostly basically one card that is lying on the same switch, and the second card is, for example, on a different switch that have a big, very close proximity from the TOR perspective, right? To not introduce latency, but the paired card will be definitely on a different switch.
Yeah, understood. So I think in that model, what you mean is the actual load balancing or failover logic will be at the SDN controller. And if one card fails, a controller would make sure that, the rules are transported into the other NIC.
No. So let me clarify on this from the HA perspective, right? So the rules are always planned on both NICs at the same time, right? Okay. So we want to have basically two cards working in the active mode in a way that, for example, rules are transferred program also to both, right? And the two cards between themselves will need to have a logic to basically sync the flows. So controller will not be syncing the flows. There is just like high CPS, high connection per second, let's say a few millions, so this kind of stuff, right? And like controller is just too slow to sync every single new flow that is created, right? This needs to be one card talking with the another card with some direct channel to kind of sync those, right? So we'll not be doing the flow syncing. This is part of the card responsibility, right? We will only be syncing the rules. Let's say, for example, you want to have those road rules and those configuration, because the configuration doesn't change often. Configuration usually change when the customer specifies something. Let's say, for example, customer wants to add additional ACL, right? Or modify the ACL, right? So the configuration changes are relatively rare, right? The most often configuration changes that we see is in case the entire virtual network is connected with the, let's say, express route or the IPsec gateway to the on-prem, right? Sometimes the on-prem routes change relatively often. So sometimes we need to update them every, let's say, 30 seconds, right? So change the routing rules, right? But it's not very high performance updating. So those updates are relatively rare, I would say, from this point of view, right? And because the cards will have the same goal state, and the same kind of routing rules programmed by the control plane, and both will be in active state, right? And they will be seeking the flows by themselves, right? If one card dies, the other card that is advertising the same VIP, because they were in active state, right, automatically picks up, because the Tor will just continue using only those, right? So in the HA, the control plane is only responsible for making sure that the control plane rules are being provisioned to both cards, right? But then the data plane is all within the cards, right? And monitoring the health of the cards, and if one card dies, rising some SEF2 on our side that we can basically, if it cannot be recovered automatically, to kind of manually try to recover, or potentially RMA the card. And if the card is RMA, to automatically select a second backup card that they can reestablish pairing relationship with the other card, so the customer is never in this like single point of failure mode.
Yes, understood. I think it sounds like this is an area probably we have to explore more in terms of architecting better. From a Sonic perspective, we need to think about, does it make sense to have two independent instances of Sonic which are talking to each other to create this HA awareness, or have one instance of Sonic with independent components to manage to DPUs, as necessary, right? I'm not sure at this point if it's clear if we have two instances of Sonic, how they would talk to each other to have the this HA notion built in. I'm not sure if it's already existing in Sonic.
Sonic doesn't talk with each other from the point of view of the HA, right? Because Sonic is software, right? It is too slow to provide flow replication, right? So the flow replication needs to be data path feature, because it needs to be kind of almost like link rate, right? Sonic is more like for control plane. So Sonic is more like providing configuration, getting metrics, statistics, and this kind of stuff, monitoring the health, right? Sonic will not be implementing the P4 pipeline or data pipeline, this kind of stuff. Sonic is only configuration. Yeah.
Totally. Yeah, I think this is probably a bigger discussion. I don't want to hold other guys with their questions, but I get your point. Thank you, Michael.
Mm-hmm.
Okay. Let's go to Jai.
Sorry, Michael, this is Jai again. So sort of a segue into what Suresh was asking. It's a little bit of a deeper question. So let me little bit spend like a minute just on the concept I'm asking, right? So in the hardware, whenever we create state is created either naturally by the control plane update, or sometimes state is created because of the data packet, right? And data packet state, most of the time, depends on the feature, will need some kind of CPU intervention to do some processing, which we call as a slow path processing, right? And then that state is constructed and is programmed in the hardware. So my question is, and take an example. Let's say that we are doing, flow learning or some kind of learning, but before that, there is an admission control, there might be another packet transformation which is needed, and then the flow state is created. So my question is, do we have a list of items in the feature which need offload? Because if you push that function into the Sonic or to the SDN controller, where the state is constructed and then pushed back, that's just not a viable solution. Ideally, you want it as close to the hardware as possible, right? So do we have understanding or list of items which need such functions or expectation from the hardware that, these are the things I'm doing a flow learning, this kind of state is needed, please manage it in the hardware. Don't expect the control plane or the controller to construct that state.
Yeah, so let me answer this with regards to this. So controller and the control plane and managing the software is definitely the control plane, right? However, once you go to the data plane and you're starting processing the packet, right? And something different happens, and I will add to the stuff that you mentioned as an offload, right? So right now, what we have in Azure, and this is kind of what we notice, it doesn't scale, is from the point of view of the connection per second, is that we have a software part which is running the CPU, which is the VFP, which is basically something that is running on the software on every single node. And this is the part which, for example, every single packet at the beginning goes through. And based on this, the software right now that is running on the CPU decided, okay, let's do this transformation because those conditions are met. And for example, is the ACL passing or not? And based on this, it creates this kind of, this is how the flow should be, right? And offloads this flow to FPGA, which is hardware, right? And then basically usually when the packets are coming, the packets are first going to the hardware and checking if there is existing flow, and if yes, then process and do this kind of stuff, right? And this kind of offloading, like processing in the CPU and then offloading the already constructed flow to hardware is already what we have. And this solves the bandwidth problem, but it doesn't solve the high CPS problem, which is the actual initial evaluation of the ACLs to know that, hey, is customer send the packet and basically should I drop it, should I allow it, right? It doesn't solve the stuff with regards to, okay, this is the address, for example, that I'm going to, right? What should be the outer end cap, right? Based on the mappings, this kind of stuff, right? Because it still needs to be, right? It's still right now being handled in the CPU, right? So so the main reason for the stuff that we need hardware here is not really to provide the offload of the constructed flow, but to also or mostly solve the first part, which is basically the rule processing. So when the first packet comes, right, and there is no flow for it because no flow was offloaded, right, then you need to process it, right? And if you guys believe you can achieve this high, like multiple millions packet per second processing in the CPU, then definitely I know that basically we cannot do this unless, based on my understanding, right, unless we actually build something like a P4 pipeline and do this kind of stuff in the hardware that actually all the lookups can be handled instantly, right? So basically we want to offload the SDN to the hardware with as minimal stuff that is actually in the software in CPU.
Right. So if I may interrupt. So yeah, so like in the Dash appliances, there's no CPU sitting there, right? The appliance itself just is doing the power management. But
Yes.
in the smart switch concept, you have a pretty beefy CPU sitting there, right? Both
That's correct.
in the CPU and in the switch itself. And there's a lot of processing which can be optimized across the switch and the DPUs, right? So my ask here is probably is it possible to have those list of items which you think are a good candidate to offload into the data path?
So based on what I know for sure from the offloading, so it's like this, like because for me the stuff is, I would say like this, I don't care what is really offloaded as a hardware versus what is processed in the software CPU, whether the CPU is on the switch or the card, right? I don't really care so much. I care mostly about hitting this high CPU. Sorry, not high CPU, hitting the high CPS, right?
Yes, correct.
And if you guys believe that you have some proprietary knowledge and some way of designing the system, then actually can provide a high CPS and reach, for example, there's like 4 million CPS per card, those kind of stuff, right? With using CPU, right? Then you guys are free to do so, right?
Okay.
But the one thing I want to emphasize with regards to the switch perspective, right, is that we definitely need to think from the point of view of the availability, right? Because when we know the cards are dying, because even right now when we are playing with basically some cards on our side, right? For example, let's say one card died because of something, right? And the idea is also from our point of view, what is our availability story as the cloud, right? If the availability story is always entire device, right, that it dies, right, because it can die, right, then it's different availability story than one specific card dice. And if you guys have some awesome solution that, for example, on the card, you guys can provide, let's say, 4 million CPS per card, but if you are using the processor, it gives, for example, as let's say 8 million CPS per card, those kind of stuff, right? That's the stuff to consider, right? But at the same point, like for example, if people, let's say, can deliver the, let's say, 4 million CPS per card, right, and give us availability set of being one single card as a single point of failure, right? Not the entire device, right? That's also different, right? And also there is a question: can we do this? Consider the beefy CPU. Can we do this in a way that one card being highly utilized is not jeopardizing the other card's performance? There's also open question. So I don't have a clear answer to this, right? Because we never tried using kind of very beefy CPU. Actually, let me correct. We kind of tried, right? Because we have a chassis we have right now a chassis that has basically multiple FPGAs with normal NICs, and we are doing all the processing in VFP, which is running on a host, which is also beefy host, but it doesn't scale as much based on our testing than just dedicated hardware with this. I mean, potentially you may get the different results in your prototyping, but I know we try with the FPGAs just sending behind normal monitoring card and doing all the processing in the CPU. And it just didn't get so much high
and
results.
Michael, if I can break in, Liwa gave us a really great explanation of why we weren't using the CPU on the switch. You know, I have that documented in my email. I was looking it up a minute ago. So I have that, and you can reach out to me. So just FYI.
Okay.
And, now, is it Silvano or Gerald? I'm the order of questions. Gerald, I think you dropped, but did you have a question, Gerald?
I wanted to comment to the, we don't care. Well, I'll answer one question about why we do Sonic first in the NIC, because it was a choice. And Gowan brought a lot of good points on that. But you do realize that in Sonic case, we already have FIPS compliance, and it's already deployed in government networks. And that would be a big thing to lose. And also in the Sonic case, it's already built upon container management, and all of the management activities around that allow us to add and delete containers. So that was just a couple of things. But the second thing is, this program started with the premise of going to software for any reason is why we're having CPS issues. And so our implementation that we have today doesn't go to software, even for exceptions. There is no exceptions that go to software. And that's why we get high CPS. And the reason we can do that is you can build a generalized stack in which is infinitely complex, but allows you to do infinite different things, and you'll end up going to software, and you'll have poor performance like we have today. This kind of consortium here is talking about what actually happens in a data center is not that complicated and can be described distinct people or behavioral models. That's what we agreed. You don't have to implement it in people, but just the behavioral models. And by doing so, you can do everything in hardware. You never need to go to the software. Should you choose to go there, you're going to have HA issues and whatever. And if you solve them, we're not preventing you from doing it, but we are giving you the recipe that you don't need to go to software. You can do everything. We don't see a smart NIC on the market that could not process what we're talking about in the hardware data or in the data plane. So that is the goal. But if you need to for some other reason, or you have some secret sauce that you want to use, we don't prevent it. You just need to provide two things: the exact same behavior, including HA, and the CPS, because without the CPS, that's what this whole project
That's what it's about. Yeah.
About scaling connections per second.
So do we have a requirement or not? Meaning, shall we spun the packet to CPU for slow path processing or requirement?
No, we don't today.
But I thought I heard a conflicting statement. Michael was saying it's not a requirement, and Liwa was saying that it's not a requirement.
I'm not saying
what we're saying is
it's not a requirement. Yeah.
It is a requirement. Okay.
No, it's not. It's not. It's not a requirement to basically spawn it to the CPU, right? Why?
What we're saying is it's not a requirement to go to software because we're defining everything that you can do in the data plane. Should you go to software, we're not saying you cannot, but you will have to solve your own HA issues, your own issues of CPS, because as soon as you go to software, your CPS is going to drop. If you have a secret sauce that you have a bunch of DPUs that you think that won't happen, fine, but we know from practice, we can give you an example.
That makes sense. I agree with you. I mean, that's what my question was originally. So it looks like it is a requirement that we should handle the slow path processing in the data path. And then my question is that what kind of requirements, right? So I was looking for some details on that. Right now, it's very, very abstract. I was about to say fungible, but it's very. So I need
the requirements should all come. So I don't know if you've been to every meeting, but the requirements come in the form of the documents, which we're going to add more, it looks like, and the behavioral models, which will be an exact requirement. The behavioral models will tell you exactly what you need. The documents are human readable, and we already have, I think, 3 documents up there, but we'll get the HA document up there probably within the next month for sure.
Okay, got it. Sorry.
I really want to get to John. He's had his hand up a long time, and we have 5 minutes left. John?
Yeah.
Are you still here?
Yeah, I'm here. Can you hear me?
Yeah.
Okay. So, Mikhail, you mentioned, that route updates, like ACL updates, maybe mapping updates that are like relatively infrequent. But I would still like to understand, like, what impact do those updates have on like established flows? Like, for example, if an ACL was queried in order to insert a flow into the flow table, and now that flow is established, but yet the ACL changes, like, is there an expectation that that flow needs to be reevaluated with the newly programmed ACL? Or is the expectation that the flow as it existed when it was established, it's sufficient to maintain that flow in the flow table?
Yeah, so let me address this. So because we are designing something to be on pair with current SDN and what behavior customer right now are experiencing, right? Right now we do reprocess the flows which are already created, right? But what I'm talking about the redoing, right? We are doing this in a slow path, right? So for example, because we don't guarantee the customer that if he plums the ACLs or change the ACLs, right? The ACLs there's like immediate effect in milliseconds or whatever, those kind of stuff, right? So it's more that let's say some ACL change to deny, right? We do reprocess those flows, but those are being reprocessed in a kind of slow way. And right now I can tell you how we are doing this in our pod is usually in VFP, there is something like a generation of the config on the generation ID of the config or the mapping, this kind of stuff, right? And where the packet comes to existing flow, there is a quick check against the generation, right? And if the generation is different, then basically this packet gets reprocessed, and the flow gets dropped. So this is how we are handling this, right? And there is some low running thread that is doing this in the background for also others to kind of drop those flows, or we sometimes let them expire, this kind of stuff, right? So yes, there is expectation mostly because we need to make sure that the current experience is there for the customer, because the customer just basically deploys the VM and says, I want this VM to be faster. They have no clue that we change the stuff underneath, right? So from the behavior perspective, it should work exactly the same as current SDN.
Right. Okay. Understood. Thank you.
Okay, so we have 3 minutes left, and Michael, the 10-minute presentation has turned into this. So thank you for coming. Could we take just maybe one more from Narajan, if it's quick? Broadcom?
Yeah, thank you, Christina.
Yeah,
This is, I think, just clarification.
Yeah.
So, Michael, in this diagram that you have, if I were to step back and look at the slow path functions, they are all match action lookups, right? ACLs,
Yes.
any route lookups. Are there any functions in the slow path that don't fit the match action paradigm? And I could give you examples, but I want to hear your answer first.
So the actions then don't fill the match. So a few things, like because in the ACLs we have different ACLs group, right? So for example, the packet needs to pass through all the groups and be allowed by all of them to for example finally leave, right? But for example, there are some actions which after, so basically there is like matching and there is action, right? So the matching, for example, hey, I'm matching this specific based on, let's say, VNI ID or based VNI ID plus, let's say, source address, destination address, and this kind of stuff, right? But then the action can be either a static action that says like, hey, always basically do this kind of npack, ncap and this kind of stuff, right? But the action can be like a second type of action, which is, for example, doing the mapping lookup, right? So for example, the outer ncap, right, is really using the dynamic IPs depending on the destination to which you are going. So even though there's, for example, one route entry saying that, say, the entire 10/8 goes to VNet, because the routes are processed using LPM. So that if we plan basically lots of route entries, which is /32s, right? And the customer plans, let's say, /16, this kind of stuff, right? And then /32s will always win. Versus, for example, if customers' intention based on the LPM is really that VNet traffic is /8, and some he wants to intercept only some part of the traffic as /16, right? Then only this part of the traffic should be intercepted. So for example, if it's not hitting the /16, it's really hitting this one route, which is called the VNet route, which is 10/8, right? Because it's the second one based on the LPM, right? But then depending on to which IP you are going, right, the outer ncap will be constructed in different way based on the mapping, right? And in case of some additional scenario, which is private link, sometimes this ncap is also doing additional transformation of the destination IP address from IPv4 to IPv6, right? So matching is definitely condition based, but then there is usually second level for the routes, for example, lookup based on the mapping, based on the destination IP and this kind of stuff.
Sure. So I would summarize what you said as conditional matching and some sophisticated resolution, right? But there are other things. For example, let's say as part of the packet transformations, you need to do NAT. Okay. Now NAT requires, let's say, for a first packet that you assign a new mapping from a pool, and this is a function that cannot really be simulated as a match action, right? Because now you have a pool of IP addresses and ports. You need to know which mappings are free and which are used, and you need to pick a new mapping to assign it to a new flow. When the flow dies, you need to be able to release that mapping.
Release it. Yes. So let me answer the NAT part, right? So we explicitly didn't. So right now we specify more like static NAT, like, because this is we need for creating the basic VIP communication that we either have right now. So we have three different kind of modes. One mode is that basically we are assigning something which calls instance level public IP, that all the traffic coming on all the ports, or for example TCP and also TCP, let's say UDP, like always gets statically NATed just the source IP and destination IP, right, to the specific, let's say, VMCA, and there is no need to do this dynamic port lookup, right? Then there is also second type of NATing where, for example, traffic arrives on port 80 and this needs to be redirected to port 8080 locally, right? It is also static type of mapping, NATing, right? And then when the replies comes back from the port 8080 to port, needs to be mapped to port 80 is also static, right? The only thing when we have dynamic NATing, right, is more like outbound SLB scenarios, right? And right now there is two things. There is one thing is that we are not blocking based on this, right? Because we have something that SLB team has, which is called Managed NAT Appliance, which means that right now we have a solution for them saying that, hey, if you want to have outbound connectivity with controlling the NATing ranges and this kind of stuff, then just set up the next hop that goes to the internet, to not go directly to the internet, but to go through this Managed NAT Appliance, which means that basically is normal simple ncap, that we are encapping the packet and the underlying outer IP is going to the Managed NAT Appliance, and this Managed NAT Appliance decap it and then decides to basically forward it up and does all the stuff with regards to port mapping, this kind of stuff. So it's basically done there, right? So we are not blocked with all the advanced SLB scenarios, right? We do have discussion on our side, right, to bring some basic potential NAT management to the hardware, right? But this is a second step in the SDN, right? So even if we deliver right now the first version that just supports SDN functionality with a static NATing of the IPs and ports, this will light up majority of the scenarios, right? And with all the complex scenarios, we'll be going through, hey, you want to have dynamic NATing pool, this kind of stuff, go through this additional managed NAT appliance, right? And then as a second phase, right, we can discuss advancement to this to kind of phase 2, how to add NATing in the hardware.
Okay.
Okay, guys,
Okay. And
who has 10 o'clock meetings? I hate to break it up. Michael, do you have a 10?
I have 10. I can probably spend 5 more minutes, and then I also need to go to the other meeting, and then we can continue potentially next week.
Okay, or
But
okay.
before Christina, I would like to finish one person at least.
Yeah,
so we can
Renato.
basically,
is it Renato?
like no, I think Nirajan, I think you didn't complete yours, or you completed.
No, so the next follow-up question was, if there is a phase 2, is there a timeline for that? And in addition to that, are there any other functions which require something in the slow path processing that doesn't fit the match action paradigm? I'm trying to understand the broader scope of where this project is going and where new requirements could come in later.
Yeah, nothing that I can think of right now with regards to this dynamic allocations and this kind of stuff, to be honest. And with regards to timeline, this is something that our PM team will need to think and will decide on the phase 2 with.
We're just trying to get VNet to VNet out the door, guys. I mean, we need to focus on that. But I can appreciate looking forward into the different scenarios. Is there a tiny bit of time to answer Renato's question about Icmp processing?
Yeah, my question, I've just 2 examples that were in the the side document. One is Icmp. I'm expecting that's expected to be done in hardware, and the other one is adding that's done in private link. I'm expecting that's to be done by the SDN control plane, setting up those NATs for private link as opposed to being done in hardware. Is that so? In other words,
so all the NATs for the private link are mostly static stuff. Okay. So we'll plan it as a mapping, right? And then the hardware you can optimize it. Yes, but there is also the stuff that part of this is kind of like part of the transformation of the private link is also that some IPv4 address, for example, needs to be extracted and put in some place when there is IPv6 address being constructed, right? And it is normal. It can be. There is basically no need for the allocation. It's more like calculation. So this can also be done in hardware, right?
Yeah, and I just to be clear, you didn't say it for Icmp. You're expecting that to be done in hardware, right? For the NLB, the Icmp that comes in for the NLB on the redirect.
Not really my strong expectation, and I'll tell you the reason for it, right? Because the Icmp for the redirect, right, is optimization on top of the connection that is already established, right? So if you can quickly switch the traffic, sure. If not, then few additional packets will go through Maxes. Not a big deal, because the Icmp packets also on our control plane, sometimes, for example, the Icmp redirect packets get lost, and Maxes need to retransmit them, right? So I would say if you can do this in hardware, that's super awesome, right? I don't think we have any strong requirements or guarantees to make sure it's done in hardware.
Okay. Yeah, I understand. Thank you.
Great. So I want to say thank you to Michael for coming and talking to all of us. Michael, thank you for your time. I don't expect, we want you here every week. I know you have to deliver the functionality, but maybe in a couple weeks or so. And yeah, so thank you, and thank you everyone else for attending and all the great engineering questions. I appreciate it, and I'll do the recording and release you to your 10 o'clock meetings, and I'll type up notes like I usually do by Friday.
Thank you, Michael.
Okay, all right.
Awesome.
Thanks everybody.
Thanks,
Okay,
bye.
talk to you later.
Thank you.
Bye-bye.
Thank you. Bye-bye.
Bye.